Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand humor? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, Dave Ansell and Chris Smith. Got loads of questions coming up here as well. I'm going to start with one from Mundo Pace, who says, what happens if you are travelling at the speed of light, then turn your headlights on?
First thing is, you couldn't actually be travelling at the speed of light. So imagine relative to us, you were going at maybe 99.999% of the speed of light, so almost there. If we looked at you and you turned your headlights on, it would look like the light coming out of the headlights was going just very slightly faster than you were. But if you looked, it would look like it was going away from you at the speed of light. Because the really strange thing about the way the universe seems to work is that everything changes in order to keep the speed of light constant. Your time will change and your space will change in order to make you think that the speed of light is still going at the speed of light. Time and space will warp and change shape in order to make the speed of light go at the same speed. But the speed of light is always constant. So if we look at you, it'll be going at the speed of light. Look at the light, it'll go at the speed of light. Or if you look at it, it'll be going at the speed of the light. Just everything else will change in order to let that happen. It sounds absolutely crazy, but it is the way the world seems to work, or the universe seems to work.
All right, so the universe is changing it.
It all works, and the universe doesn't really change. It just depends how you look at it. It can look very different. If you look at it when you're moving, it will look very different to how if you're not moving.
Right, OK, Mundo from Norwich. I hope that makes some sense for you. There's another one here, which is coming from Steve by email, and he says, if matter can neither be made or destroyed, where did it come from in the first place?
That's one of the big questions where everything came from. Matter can't quite not be made or destroyed. It can get turned into energy, and energy can get turned into matter. So if you have an electron and you get something called an anti-electron, which is another type of matter, and the two hit each other, then they produce a load of energy and the matter disappears. But if you consider mass as a matter and energy was all the same thing, where that came from, we don't really know. It's something which happened at the very beginning of the universe, and it's so far back that we don't know. Fundamentally.
Right. Because Steve goes on to say, does that mean that we are made up of atoms that are as old or even older than the universe itself?
The atoms themselves can get changed. I mean, in a nuclear reactor, you split atoms, so you take one atom and change it into a different set of atoms. And in fact, all of the atoms which are made up of, apart from the hydrogen, most of them will be made in stars, or actually start exploding stars, supernovae. Any metals heavier than iron were made in supernovae. So the atoms can have got rearranged, but the particles making them up and the energy that made up the atoms has been there since the beginning of the universe.
Well, thank you very much, Sir Stephen. Thank you very much, Dr. Dave. Now then, about the blue tongue plague, John says, how is it possible that we can blame a minute continental midge for the blue tongue plague?
Well, let me ask you another question. How many people do you think catch malaria every year?
I don't know. I know the statistics are quite phenomenal, aren't they?
There's about 300 million people every year,
Crikey.
and about 1% of them will die, so that's 3 million deaths a year. Now, that's in human terms,
Yeah.
and that's malaria, and of course the thing that spreads that is something not that different to a midge. It's a mosquito, a blood-sucking insect. So these insects are in fact the most dangerous animals in the whole world. If you ask people what's the most dangerous animal in the world, they invariably say sharks and poisonous spiders and snakes and things, but actually on a weight-for-weight basis, in terms of the number of corpses, if you stack them all up, time and again, it's always the mosquito, because it spreads malaria and it spreads dengue and it spreads a number of other infections which kill people on a huge scale. So to me, the finding that midges spread blue tongue around is not that amazing, because malaria just makes the whole thing pale into insignificance, Sue.
Yeah, absolutely. As far as symptoms are concerned, you know, what should people be looking out for? Because we say, malaria and that kind of thing. So what should we be looking out for?
It's mainly a fever, and the thing that we say in medicine is the fever in the returning traveller, someone who's been to an area where we know there is malaria, and then they come home, and the right amount of time later, they develop a fever, and the shivers and the shakes, and then you take some blood from them, and the way we diagnose malaria is intriguing. You put some blood on a glass microscope slide and squidge it underneath a cover slip, so you make a sort of thin film of the blood, and put it under a microscope, and you look for the parasite in the red blood cells, because malaria is a parasite, so Plasmodium is the name of it, and you can see them inside red cells, because part of the reason malaria spreads in blood is because it homes in on our red blood cells, gets inside them and then grows in there. And that's why it's transmitted in blood, because when a mosquito comes along and drinks the blood, it sucks up some of the malarial parasites with the blood that it's eating to feed itself.
Ugh. Horrible things. Right, let's go from blood to oil. June has sent a text in to say, when was the biggest oil spillage in Wales, and how many tonnes of oil was it, and where in Wales did it happen?
I didn't know there'd been a huge Welsh oil spill that had made kind of international headlines. I mean, there have been lots of oil spills around the world, and they're always devastating because you end up with literally 250,000 tonnes of crude oil washing up on a beach. And crude oil's horrible stuff. If no one's ever seen it, it's very thick, viscid, sticky, and of course it repels water, so it clings to itself and other oily things, and birds get into all kinds of terrible problems because it sticks to their feathers. It stops the oxygen reaching the water, so it can cause the water to stagnate underneath, and this can cause problems for wildlife. And because crude oil is full of other nasty chemicals and carcinogens, it's a major health risk, so it's bad if it does get out. But I'm not aware of Wales having a massive disaster, but then I'm not very up on the Welsh oil industry, and maybe someone could put me in the right direction.
Mm-hmm.
Apparently there was a fairly large oil spill from the Sea Empress oil tanker in near Milford Haven, because Milford Haven's where all the big oil tankers, they can't get up the channel because it's not deep enough.
Sure.
So they empty some of the oil out at Milford Haven, and then it moves around the UK in pipes, and they go up to Rotterdam to empty the rest of it. Apparently a big supertanker called the Sea Empress went aground and spilled maybe 65 or 70,000 tonnes of oil.
Ouch.
In the late 1990s, I think, 1996. So I'm guessing that's the biggest one. I haven't heard of another one.
No, OK, thanks for that. June also asks, how can you tell how polluted the air in your area is?
Best bet that I've found, having a quick look on the internet as you do, is there's a thing called the UK Air Quality Archive at www.airquality.co.uk, and that's got a list of, there's a whole lot of air quality monitoring stations in the country. There's one of them in central Cambridge. There's mostly they're in the centre of towns. There's a couple of them out of the towns. Yeah. And you can find a list of what the automated instruments were reading today, and there's an archive over the last few years as well. So I'd have a look at that, although if you don't live in the centre of a town, it probably won't help you an enormous amount.
What was that website again?
www.airquality.co.uk.
Thank you.
It's run by the government.
I've learned something now. Now, here's an interesting one. Mandy in Lakenheath asks, if the black box in a plane always survives a crash, why isn't the rest of the plane made of the same material?
Unfortunately, you could make the plane out of the same material, but the people wouldn't be made of the same material. And the people decelerating very, very fast is what kills people in plane crashes. It's the sudden trauma. You're going from hundreds of miles an hour to a standstill in less than a second. And unfortunately, your body isn't made of that material that can withstand this and bounce back elastically.
Yeah, the other thing is that even if you did make a plane out of the same material, it almost certainly wouldn't survive. Because if you imagine something like a match, and especially if you're trying to compress something, and most accidents are when things crash and compress. If you imagine compressing a match, trying to squash it between your two fingers, your fingers would probably die before you'd hurt yourself far too much. You wouldn't be able to crush it long ways just between two fingers. But if you imagine something made out of the same material but maybe sort of a metre long, it'd be very, very easy to break it. Because if something gets longer, it gets much more flexible, and it actually gets harder to make something strong. So a plane, to make it strong enough to survive, to make it as strong as the box, would be almost impossible on the scale of a plane. And it would be incredibly heavy if you did do that. And also, the bigger you get, the more the forces are when you crash into something. So you've got more energy to dissipate. And so there's a thing that I remember hearing, that if you drop a spider down the well, it just goes down the bottom, it walks away. You drop a rat down the well, it'll fall down, it might break a leg. A cat might break a leg. You drop a human down the well, they'll probably die. But if you drop a cow down the well, it'll actually go splat.
Interesting thing I can add to this, Dave, actually, scientists have proved, no animal rights people phone me up, please, but if you drop a cat out of about a 4th floor window, it's more likely to die than if you drop it from a 9th floor window. And they've done experiments showing why this is. When you drop the cat from the window closer to the ground, the cat kind of panics and thinks, oh God, I'm dropping, and it tenses up its muscles. And when it lands, of course, all of the energy of its fall gets exerted right the way through its stiff legs and its stiff body with all its muscles contracted and tensed. And this is very bad for the cat's anatomy. But when you drop it from a much greater height, the cat panics initially, realises it's falling, thinks, oh well, and then relaxes again. No one knows exactly why, but it relaxes again, and then when it slams into the ground, even though it's probably going a little bit faster, but not much, because it's reached terminal velocity, probably from the lower floor anyway, it hits the ground, and because its muscles are all relaxed, they act like giant elastic springs, and they soak up a lot of the energy, and its rib cage hits the ground as well, and this wins the cat a bit, but it soaks up some of the energy, and the effect is to decelerate the cat more slowly than if it just lands on rigid feet, and it's much more likely to walk away. At least that's what science says, and it's been proven.
Oh, how scary is that? I mean, there have been some people who've, thrown themselves off of buildings and things a long way up and survived, haven't they, or fallen because it's been a long way down and obviously the same principle.
Well, I think cats are slightly better because having 4 legs, they're actually distributing the force over 4 limbs, not our 2. So if you drop straight down, you're distributing all of the energy straight through both of your legs. If you land flat and you land on your rib cage, yes, you'll probably break a lot of bones, but you can dissipate the energy because you're spreading the area of your body that's taking the force of decelerating you, the earth pushing you back in the opposite direction. It's spread over a much bigger area, and therefore the actual amount of energy going through each bit of your body is lower, and therefore you're less likely to get as bashed up as if you drop straight vertically. I was aware of someone that tried to kill themselves by jumping off a bridge. They jumped off a bridge onto a road that had been freshly resurfaced, and they hit the road, and it was sort of tarmacy stuff, a bit soft, and their feet broke off sideways, and their leg bones dug into the road surface. Not very pleasant, and they had to be sort of carefully removed and then put back together in hospital, and I think they survived, actually. It was very lucky.
Ken of Hockley has a question. He says 2 related questions. Can you transplant a heart after a heart attack? And can all transplants be put into the opposite sex?
Oh, the answer to that's definitely true. Yes, Ken, good question. A heart attack is when blood flow to the heart is interrupted. And the heart has its own blood supply. It's got coronary arteries which come off of your main blood vessel, the aorta, and they run around the outside of the heart, giving off little branches that supply the muscle. And if those branches become blocked, usually because there's a deposit of what's called atheroma in the wall of the artery, then the blood flow ceases to that bit of the muscle. And because the heart is so active, it burns off huge amounts of energy and oxygen every given second. And if you deprive it of its blood supply for any fraction of time, you can begin to kill the muscle cells. But you can have a very mild heart attack. You can have a small interruption to the blood flow, and it'll leave the heart largely intact without too much damage. And so there's no reason why, if you were desperate, you couldn't transplant a heart. Say you had a twin, your heart clapped out, and your twin was, say, killed in an accident. There would be no reason, if your twin had an otherwise healthy heart but may have had a heart attack in the past, there'd be no reason why you couldn't transplant the twin's heart into you. And the idea of using an identical twin is that you'd be genetically compatible and there'd be no problem with rejection. In terms of the difference between the sexes, there's no reason why you can't move a lady's organ to a man or a man's organ to a lady. The main constraints are they genetically compatible? And we're looking at how the immune system recognises things rather than sex, because the immune system isn't sexist. It doesn't care what sex you are. It's just more interested in how different you are. Mm-hmm. And the other point is that men's organs tend to be a bit bigger than women's organs, so you also have to factor that in. If you've got a massive, great, strapping guy and he's going to give a liver to a lady who's very petite and small, there might be a problem of size. So you also have to account for making the organ fit. But in general, no, there's no reason why you couldn't transplant a man's and a woman's organs from one to the other.
Thank you very much. Martin has sent a text in. Can I ask the good doctor, what is the cause of acid reflux and is there a cure?
Acid reflux, also known as gastroesophageal reflux, Martin, is where the acid that's made in your stomach is hydrochloric acid. You have specialised cells that line the stomach, and they're called oxyntic or parietal cells. And what they do is exchange ions of one chemical called potassium for a second chemical, which is called hydrogen. and they pump out these hydrogen ions, and they're the acid, into the stomach. And the stomach is specially geared up to protect itself from this acid. So there's a layer of slime or mucus on the surface lining of the stomach, which stops the acid getting at the wall of the stomach. The cells that line the stomach also grow very fast, so they can replace any cells that get worn away. And as soon as the stomach acid leaves the stomach to go into the small intestine, the juices that come out of your pancreas and out of your gallbladder are very alkaline, and this neutralises the acid and stops it damaging the small intestine. But the pipe that carries food from your mouth down into your stomach, the esophagus, doesn't have the same degree of protection because food's only supposed to go one way in the esophagus, from your mouth into your tummy. And there's a valve at the bottom of the esophagus called the cardiac sphincter. And normally the muscle there clenches down tightly and holds this tissue together so that stuff in the stomach can't come back the wrong way. But there are a number of conditions. One of them is called a hiatus hernia, which is where you get a relaxing effect of this sphincter, and some of the acid can bubble up into the esophagus. Mm-hmm. And because the esophagus doesn't have the protection that the stomach lining does to ward off the acid attack, it irritates the lining of the esophagus and burns, and it produces this unpleasant sensation of rising burning and heat and pain going up the middle of your body, sometimes even into the back of the throat. It's very uncomfortable. And if it's allowed to continue for a long time, it can cause ulceration in the esophagus, it can cause scarring and stricturing, so it's hard to swallow things, and it can also lead to cancer. So it's worth making sure that this doesn't go on for a very, very long time, because it can cause this condition called Barrett's esophagus. The way to ward this off is to reduce the amount of acid in the stomach. And the way in which doctors go about that is by giving a family of drugs. And there's a whole lot of drugs that are out there now that are really good with very few side effects. And one of those is a drug called omeprazole, which is one of the first ones. And it locks onto those cells I mentioned earlier, the parietal cells or the oxyntic cells, and it inhibits the enzyme that makes those acid ions go out into the stomach. So it stops the stomach wall producing acid. And if you cut down the amount of acid in the stomach, this reduces the reflux. You can also do clever things to reduce the hiatus hernia that some people have, and you can also do something where you wrap some of the top of the stomach around the base of the esophagus with an operation called a Nissen fundoplication, and this also reduces the amount of acid bubbling up. But people try and use drugs rather than have an operation if they can.
Sure, and of course diet can help, can it?
Well, being a bit on the large side, having a lot of pressure around your middle can encourage esophageal reflux. So if you lose weight, that does seem to be better. And also smoking increases the stomach acidity, and you're more likely to have acid bubbling up if you smoke. So if you can kick the habit, that will also help to reduce the problem.
Anne says she recently heard that a person can live off baked beans alone. Is this true? And can you elaborate on it? I think Dave's probably a living testament to living on baked beans alone, are you?
I've never done even that much baked beans. There was a Czech guy when in my undergraduate who lived off virtually nothing but baked beans and bread. But I don't know what's in baked beans. I guess there's
beans is in
carbohydrate
beans in
and
there, Dave.
Protein. Yeah, I mean, as in sort of nutritionally, Chris.
Some tomato. Beans have got a lot of fibre, and this is what frustrates the bacteria in your guts when you eat them, which is why beans are so what are called fartogenic. They make you fart. Although men much just the same as women, so there's no sexism here. I think that beans are pretty good as a balanced source of materials in your diet. They've got vitamin C because they've got tomatoes. They've got some B vitamins because of the tomato juice. They have got soluble fibre, which is good for keeping you going regularly and keeping everything happy and hunky-dory. And they've also got complex carbohydrates, which are a useful long-term store of energy because the body has to chew the carbohydrates up before they turn into sugars, which you can then absorb and burn in your body. And for this reason, they tend to fill you up for quite a long time because it takes time to break the beans down, and then you absorb the goodies, and then you get the benefit. So they're a good sort of long-term fuel source.
Well, I wouldn't recommend doing it deliberately unless you're in a dire straits, because it's always best to have a bit of a varied diet, I feel.
Right, OK, let's get on with another question here. Peter says, if you have a head-on collision at, say, 50 miles per hour with another vehicle doing 50 miles per hour, you would think the speed you would be thrown at would be at 100 miles per hour, but it's actually 400 miles per hour. Why is this?
I think there's various things going on here. First thing, if you drive into a wall at 50 miles an hour, say that does a certain amount of damage. If you drive at another car doing 50 miles an hour, that's the same weight as you, then in fact you'll both just stop exactly the same as if you'd hit a wall. So it's exactly the same as driving into a wall at 50 miles an hour. If you drove into a lorry doing 50 miles an hour and you were doing 50 miles an hour, you'd start off going 50 miles an hour forwards. You'd end up doing 50 miles an hour backwards. So it's a bit like having a crash at 100 miles an hour. Now, the energy that something has is proportional to the square of its speed, so the speed times the speed. So if you double the speed, the amount of energy goes up by 4. So if you drive into an articulated lorry at 50 miles an hour, the amount of energy, it would be as if you crashed into a wall with 4 times as much energy at 100 miles an hour. I think that's what he's thinking about.
Why is that? Is it just
energy? If you think about it, it's a force times a distance. So if something's going faster, you've got to apply the same force the same amount of time, but it's gone for more distance. So the faster you go, the more. If you're going at 50 miles an hour, adding 1 mile an hour energy is a lot more than if you're doing 20 miles an hour, because you're already going faster.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.